Today we are going to be talking about the DJI Mavic 3 and specifically its GPS module. Over the last couple of weeks there has been a massive amount of noise, hearsay, speculation and frankly nonsense with regards to the cause of some of the issues that people are having with the Mavic 3's GPS performance. There has been some specific accusations with regards to the chipset DJI have chosen, as well as some things on the GPS module as well, around that they're causing the problems that some people are seeing. Today, we are going to try and address some of these things specifically around the GPS module. I'm going to share with you guys some information, hopefully you may not be aware of and you've not seen anywhere else. And I'm also going to give you some of my own personal thoughts on some of the issues people are facing. Now, just to be clear, this video isn't full of the answer to the problems people may have, because the reality is still we don't know. I can talk about the module and address some specific things on that. As for the wider causes of issues people are facing, I can't tell you because I still don't have a Mavic 3 to be able to test it on specifically, and there are things that we still don't fully know, but what we do know I can share with you guys and hopefully put to bed some of the things that has been said. Just before I jump into it, I just want to say, if you find this video interesting, please do consider hitting the subscribe button. If you'd like to support us to keep making independent content like this, please consider checking out my Patreon as well as buy me a coffee. To make this video, I went out and bought a Mavic 3 GPS module at a cost of £90, and I've spent the last week testing that, and I would not be able to do things like that without your support. So if you would like to help us keep funding investigations like this, please do check out the links in the description. That way you're supporting us to be able to keep doing these things moving forward. Anyway, let's get on with this video. Let's take a closer look at the module first of all, and then I'll move in to some of the behavior I've observed, talk you guys through that, and then give you my thoughts at the end. You can see I've got the module here itself, and I've currently hardwired it for connection to an FTDI adapter for being able to access the serial data from the module. Now, what I'll do is jump over to the desktop and actually show you some high-res images that I've taken just to walk you through everything. Overall, there appears to be nothing majorly wrong from a hardware point of view design-wise with the module. It has a large 25 by 25 GPS antenna. Everything is shielded well. This module does have both the GPS and the ADS-B in or AirSense chipset on board. There is a backup battery, which we'll talk about, and there is an unpopulated area, which I'm going to talk about in a minute as well specifically, and then we have a connector. But other than that, there really isn't anything specifically good or bad about this module. The design itself seems as would be expected. Okay, so looking at the top side of the board first of all, you can see we have our large GPS antenna, and as I've said, that's a 25 by 25 mil unit. It's not branded, so we don't know who it's made by, but it's not a small antenna. It has a good size to it. Around the rest of the board, we have a couple of connectors up here. We have these little metal sort of clips, or these little connection spring clips, which I'll talk about a bit more in a minute, which are located either side of the board because they're quite interesting actually, and they're related to the ADS-B. And then you've just got a couple of screws to hold the IMU in place, which is also attached to this board as standard. If we flip around to the bottom of the board, here you can see the main RF area. On the left, we have our ADS-B in system, which is under this can, and the big can in the middle is the GPS chipset. We have a battery located here. We have a voltage regulator here, as well as some more voltage regulation down there. We have then another connector for power input with a transistor. You'll also note that there is an unpopulated area up here, which I'll go into in a bit more detail as we move through, because that has been something of great interest. But to be honest, I don't believe it is. I think it's just another sensor, which we'll come on to in a second. If we move forward, take the cans off, you can see the chipsets below the cans nice and easily now, with the ADS-B on the left here, and again the GPS in the middle. Remember earlier where I mentioned about those little sort of spring clips on the other side of the board? The reason they're quite interesting is on the ADS-B side of things, or the AirSense, there are two antennas. You've got a circuit which goes down this side here to this little antenna spot, but it goes through the antenna spot and out to there. And then you have this one on the top side, which again goes through the antenna connection and then out up here. It actually goes out to those clips on the other side of the board. So what it appears you have on the ADS-B side of things is antenna connectors here if they need to use them, but those clips on the other side, so if I just go back to the top side, this one here and this one here, can then bridge against something else in the Mavic, so say an antenna fixed to the top of the plastic to give it its signal reception. I assume DJI is doing that in the assembly. It isn't something I've gone and checked, but it could explain a little bit why some people have had some issues with AirSense if those connections aren't quite working as expected. If we label everything up, as you can see here, I've said we've got the ADS-B, we've got our Ublox chipset, we've got our backup battery, and then we've got the unpopulated area. Moving in closer to the GPS chipset, the model they're using on the Mavic 3 is the M8030KA. Now, there has been a lot of controversy about this chipset, with some frankly inaccurate information stating that it is inferior compared to the usual model they use, which is the Pro version labeled KL. That other chipset is a standard chipset that DJI have used for quite some time, and this is the first time that we've seen the KA module as far as I'm aware in models. However, I'm going to be clear with this now. This chipset is a higher quality variant. It is designed for automotive applications, and it has a slightly different specification with regards to its ability to deal with heat, but its overall performance is identical to the standard variant that DJI have used in the past. There is absolutely no reason that this version of the chipset is going to cause any problems with the Mavic 3. It is a more expensive part, and it is likely DJI have had to move to this simply because of the chip shortage that we're facing globally, and there is no reason to believe that this chipset has any effect on the performance of the GPS at all. Furthermore, you will notice that there is no SQI Flash attached to this chipset. If you don't know what SQI Flash is, it is an external flash module that is added to GPS units that helps store additional information such as the Almanac data or firmware updates. It is not unusual for DJI not to add SQI Flash because these modules don't specifically require it for normal use. DJI can actually provide some of the information to the chipset from their main SoC, such as the configuration info, rather than it coming from the SQI Flash. Now, with regards to the SQI Flash, there is a lot of question marks about what the effect of DJI not having SQI Flash on the Mavic 3 GPS will have. To be honest, it is not unusual for DJI not to add SQI Flash. Having looked, they really don't add it to most of their models. SQI Flash itself is external storage for the Ublox module that allows for doing things like updating the firmware on the module and storing Assist Now data, whether it be online or offline data, and that is a service that Ublox offer to basically help get GPS data into the module to help with lock times, but that requires an internet connection to do so. The fact that there isn't SQI Flash in itself should not have any bearing overall on acquisition times, any bearing on satellite performance. It's really additional storage for login, firmware updates, and those additional features, but it isn't something that is used generally as part of the GPS setup, and overall it will behave absolutely fine without it. Moving up to this area here where we have the unpopulated chip. Now this is a QFN16 chip which is attached to the main PCB external to the GPS area with its component circuitry added. Now there has been a lot of question marks over this chipset. What is it? Why is it missing? And could this be the cause of the GPS performance issues? It is my opinion that this has no impact on the GPS at all. It is not SQI Flash, as far as I can tell, because A, it has too many pins. Generally, SQI Flash is 8. It's too small, and its pins don't go back to the correct locations on the Ublox chipset down here, so it is not attached for the data lines. It is my opinion that this is an additional compass module that they decided not to fit to the Mavic 3. It is the correct pin out, the correct size, and for me it makes sense that there may have been a version of the Mavic 3 in testing and design that might have had more compass modules or the compass in a different location. As for the reason DJI did not attach the chip but did attach the additional components, well, that one is actually fairly straightforward to explain away. When they design PCBs, they go through a pick and place machine for production that places the components on before it goes through the heat bath for soldering. It is far simpler to simply leave the reel out for that component than it is to redesign the pick and place layout that they have done for the GPS module. The pick and place would have been designed in advance, and the software will be told what components need to go where, and to go in and change that is a little bit more difficult than simply just leaving the reel out of the device, or even changing it so they don't pick that one in the first place. As for why the components would be picked, well, they are generic components and far easier and cheaper to just leave get placed on the board and not used, because the cost involved in that is so small it really isn't necessarily worth the time and effort making the changes to the pick and place process to take them off. Moving through just to show you some examples of the GPS chipsets with SQI Flash added, you can see here we've got a Ublox M8030KT, which is the version they traditionally use, with a wind bond SQI Flash located here. These are 8-pin packages with the pins on either side, and you can see it is clearly very different to what we've got on the Mavic 3 GPS module. Now, this one here does have SQI Flash added because they'll be using this to store some of the configuration data. It's different for DJI because they can push that configuration data from the main flight controller because they don't need to use separate flash because they've got that there. Here again is another module, and this one is a bit more interesting because this is a full-size standard GPS module, again with the M8030 chipset. It has the SQI Flash on the side, but note over here this chipset, which looks remarkably similar to what we've got on the Mavic 3 GPS, and that is the compass module. Again, off to the side, very similar components laid all around it as well. So again, as I've said, it's nothing that's going to have an effect. It is simply DJI hedging their bets on what options they want in the future. Now, there has been a massive amount of speculation over the SQI Flash situation. Now, we know it isn't there, but it isn't going to have any dramatic effect on the performance of the Mavic 3's GPS. The simple reality is DJI don't need it. In fact, most of their modern drones don't have SQI Flash on anyway. The reason for that is, as I've said, they are loading the configuration data directly from their flight controller. They don't need a flash storage position for it. They also don't need the flash storage for the firmware update process or a storing SysNow data. Yes, the flash storage can be used for storing Almanac data, but they can store that on board the M8030 chipset directly anyway, so it isn't really a problem for them. In the end, not having the SQI Flash is going to have no major effect on the GPS's performance. You do find traditional standalone modules will have the SQI Flash, but they need it because they're not getting their configuration from the flight controller, and they don't have that DJI software in the background handling all of that side of things. With regards to the information and accusations that that automotive version of the M8030 chipset was part of the reason it was having problems, it is complete and utter nonsense. The performance of the automotive variant is no different to the others. The biggest difference is the fact that it has a higher maximum temperature rating compared to the standard module. There is no effect on the GPS performance between any of the three variants of the M8030, whether it be the standard, the professional, or the automotive. They all have the same sensitivity, they all have the same capabilities, so that information is nonsense. It has no bearing on the issues people are facing at all. That unpopulated area is nothing to be concerned about. For me, it's simply another compass module, I suspect, and is nothing that's going to have any effect on the performance of the GPS at all. Again, to confirm, it doesn't add up for SQI Flash. It does not pin back to the Ublox module. It is completely external, and really, it's just an option that they've chosen not to fit. Next, we're going to start jumping in and taking a look at some of the data on the module's performance itself. Now, I've had to do a huge amount of testing on this, and the first thing we had to do was figure out how to connect this module up. I was very lucky that a user on Mavic Pilots has actually already done some tests on the module, and he's managed to pin out some areas, and that gave me a head start of where to look. I got it on the bench and got it pinned up first of all in the test setup, which allowed me to gain access to the serial port, and from there I've then soldered in directly, and that's allowed me then to continue with my testing properly, comparing it to other modules. For this, we have been using Ublox's U-Center software that allows me to connect directly to the module and have a look at the information that the GPS module is providing. From this, we can look at all sorts of data such as the signal strength, the sat count the satellites is picking up, the HDOP, the PDOP, and info such as the predicted horizontal and vertical accuracy of the module. We have full control over the module on the Mavic 3 and any other module I connect via Ublox as well. We can tell the module to configure it in any way I want. What we don't know though is what configuration DJI is using themselves. Because they're not using SQI Flash to store the configuration data, they are actually configuring the module themselves as the aircraft powers up. So we can't specifically replicate their configuration because we simply don't know what that is. My tests as a result of that have been in two configurations, standard Ublox and faster rate, to compare it to the likes of the Here 2, which runs at a much faster rate than the standard configuration out the box. These tests will give me an overall picture of how the module performs, and whilst we can't see DJI's own specific configuration, we can come up with some info with regards to the general performance of the module, and that's what we're going to take a look at next. Something I just want to talk about very quickly is the GPS constellation or system choice that DJI have made with the Mavic 3, because it is the first time that we've seen it. Traditionally, DJI have used a two-sat system on their drones, which is GPS and GLONASS, which is the US and Russian-based sat system. In the Air 2S and the Mini 2, DJI introduced Galileo into that mix, so it was a three-sat system at that point, but it remained the main two-sat systems, which was GPS and GLONASS. With the Mavic 3 though, DJI have made quite a big change, and they have swapped out GLONASS for BeiDou. BeiDou is the Chinese homegrown GPS system, and whilst it hasn't always been up to the same level as GPS and GLONASS, there has been huge strides and improvements with it over the last few years, with more and more satellites being introduced, and it is now pretty much up to full strength. The interesting thing with all of this though is there is not a lot of real-world use case scenario data on using GPS, Galileo and BeiDou. It isn't a widely used setup in itself, and we don't know how well that should perform across the globe because it hasn't been used on DJI's own products in the past, and there aren't particularly many other manufacturers using it widely. So it's time to start looking at some data, and the first thing we're going to look at is antenna stroke sensitivity performance of the Mavic 3 module. I've been comparing it to a Here 2 from QPilot as well as an M8Q from a Texas. The Here 2 is one of the best GPS modules I have used. It is one of the most sensitive, and the good thing about it is it also offers very similar performance from a specification point of view to the Mavic 3 module and supports all of the same constellations and configuration as well. Furthermore, I've been using the M8Q as a tester as well, which is a small FPV style GPS module, and the reason I chose that is it's nice to throw that into the mix of comparison with the much smaller antenna, and it'll give us again some nice baselines compared to the other two modules, and it'll be interesting to see where the Mavic 3 module falls between those completely different module antenna sizes and overall performance. So let's jump over to the charts first of all and have a look at where the Mavic 3 3 module came out. So taking a look at the results on the antenna and sensitivity of the Mavic 3 module, I've done a huge amount of testing on this, but the results remain consistent, and that is overall the Mavic 3 module is a little bit less sensitive compared to the Here 2. If you look at this data chart I've got here, this is the antenna performance in dB hertz between the two modules taken at both the same time, just with about 1.5 feet of separation at the same location. And you can see that overall the Mavic 3 module is around sort of 5 to 7 dB hertz lower in sensitivity than the Here 2. On a second set of results, you can see the same holds up, again with the Here 2 taking the lead in the majority of cases. Moving over to comparing the Mavic 3 module to the M8Q, which is a much smaller module with that smaller antenna, you can see that the Mavic 3 module does a much better job overall, as we would expect, and it just shows that it's not particularly bad, it's just not quite up there with the performance of the Here 2 itself. One interesting observation I had with the Mavic 3 module compared to the Here 2 is that I can't turn off the LNA. The LNA is the low noise amplifier that's used on the GPS just to help improve the reception on the module. Ublox actually have a dedicated option for enabling or disabling the LNA via software, because the antenna output provides the power for that amplifier. On the Here 2, I was able to turn off the power and actually kill the reception. However, on the Mavic 3 module, turning off the power output had no effect and the SAT signal remained the same. This would imply that DJI is powering that module separately from the Ublox module, and it does ring a question of whether they're actually controlling that LNA externally, or have they simply permanently powered it and you're just getting what you get. It does open the possibility that DJI have the ability to control that LNA separately from the Ublox module, but I think the most likely thing is that it's simply permanently powered, and it could be the reason we see a difference between the two modules is simply the different amplification levels that that amplifier is providing. So I've now moved over to U-Center, and you can actually see that the module's connected in the background. We've currently got it on the same mode as the Mavic 3 uses, and I've just actually done a cold reset and it's just acquiring all of the satellites. Now, I've spent a massive amount of time over the last couple of days trying to understand the module, look at the best configuration settings, as well as diving through Ublox manuals to get an understanding of what exactly is going on. And I want to try and share with you some thoughts as well as observations on what I've seen. Now, as I mentioned earlier, DJI have moved from using GPS and GLONASS to GPS, Galileo and BeiDou. That switch in itself has implications on the performance of the GPS module. For instance, the M8 series on the Ublox is capable of up to 10 Hz refresh rate in single sat mode. In two sat modes, such as GPS and GLONASS, it's capable of up to 5 Hz. However, when you move to a 3 sat system, including Galileo, that refresh rate reduces to 3 Hz. So there is implications of changing from a 2 sat to a 3 sat system. By reducing the refresh rate of the module, you're actually changing how it performs overall. For instance, the module is capable of getting very quick and accurate readings in 5 Hz. However, that does take longer when you move to 3 Hz, and it does have an effect on both HDOP and positional accuracy estimates. In my tests in 2 sat mode, it can quickly get down to a HDOP of 0.7 or 0.6 and give horizontal accuracy estimates as low as 0.67 of a meter. However, when you do move to the 3 sat system, you see both the HDOP and horizontal position estimates change. For instance, instead of it going down quickly to 0.7, 0.6, it takes longer to get to the lower levels of HDOP, if it gets as low at all, and the horizontal position estimates stay as low as 0.97 and don't get much lower compared to the 0.67 that you can see on 5 Hz. The overall behaviour between 3 and 5 Hz is quite different on the module, and this will have implications with regards to how long it takes to acquire satellite acquisition and how long it then takes to get to very accurate positions and how accurate they are. Now, I can't say if that is the cause of what people are seeing. But in my tests, it is clear that when you are in the 3-sat mode with the slower rate, that can have quite a dramatic effect on the performance of the module, especially if the sat signal is lower, and the module can often hang at grasping onto satellites and moving forward in that 3 Hz mode because it's simply not able to get the acquisition the same as it can in 5. Now, there has been a lot of questions over the hot, cold and warm performance of the module. If you don't know what they are, the difference is as follows. Cold start is a module with no Almanac data on board at all, so it has to boot completely from cold without any data to go by. Warm start is where it has Almanac data but no precision GPS data, and hot start is with all the data stored in the module's flash. It simply reboots and gets back to where it should be almost instantly. To compare what that would be with your drone, a cold start would usually be if you haven't used it for a period of time and it's having to download all of the Almanac and additional data as well. Warm start would usually be if you've used it a day or two ago, and hot start would be on a battery change where you've got that very latest data stored in the module that is valid for between half an hour and 4 hours. Overall, there is a difference in the performance between them, but even a complete cold start on the module should not be taking any longer than 1 to 2 and a bit minutes. There really isn't a dramatic effect overall. Whilst it does take longer, you have to understand that is normal, but it isn't the likes of 8, 9 or 10 minutes. Just to demonstrate that for you, what I will do now is force a cold start on the module, which will delete all of the Almanac data, and will now wait just to show you how long it takes to acquire satellites. Something, as I mentioned earlier, I have observed is because of the slower refresh rate when in the 3-sat system, there are times where it also seems to hang on GPS before locking onto the other systems, and I've seen it do that for as long as a few minutes, up to 5 minutes in fact. There was one time where it didn't lock onto the other systems at all. It was showing them, it just simply didn't lock onto them, as you can see it doing here. Right now, it's bringing the GPS in after the cold start. It's starting to bring in BeiDou, and it's starting to bring in Galileo as well. We've already got a HDOP of 0.8, so you can see that the module is quickly bringing in the accuracy data, and it's got a horizontal accuracy estimate of 1 meter at the moment. As time goes on now, you'll see additional accuracy kick in as the module continues to lock onto the SAT systems, but it can take some time, and it is slower simply as a result of it using that slower refresh rate in the 3-sat mode. Just to now show you the performance difference in warm start and just how fast that kicks in, we can hit the warm start button in Ublox, and again, it will force the module to reset and actually kick the system in from warm start overall. Now, there is some interesting things around the difference between Galileo, BeiDou and GPS compared to GPS and GLONASS in itself, in the sense of you're not really getting any major performance benefit from a GPS point of view as far as I can see by choosing the 3-sat system. You get similar sat counts between the two choices. For instance, on the GPS and GLONASS side, you get a lot more GLONASS sats than you do individually BeiDou or individually Galileo. What you sort of get is Galileo and BeiDou coming up to about the same level as you would get from GLONASS. You're just separating that quantity of satellites between 2 systems rather than 1, or the total quantity of satellites between 3 systems rather than 2. What I'll do now, just to demonstrate that, is just jump over to the 2-sat system just to show it's actually at this point in time picking up a lot of sats. You can see we've actually got 19 in total at this moment in time. That is more than I've usually had in all of my testing over the last few days. I'm usually getting 12 to 15. So at this particular moment in time, it's clear I've got good amounts of sats overhead, but an observation I've had on that is that can often be quite different, and I can have as low as only 5 or 6 combined between Galileo and BeiDou, so there's no guarantee you will get that high level of sat count all of the time. Just before I do that though, I'll just quickly show you a hot start. A hot start would be when you swap the battery on your aircraft. It keeps all of the data and it is almost instantaneous. The module reboots and literally bang, straight back up to the position accuracy. We're already at a HDOP of 0.7 and all of the accuracy numbers look absolutely fine. So the hot start performance of the module is absolutely fine. There's no problems with it at all. Let me reconfigure it and we'll take a look at GPS and GLONASS. So I've just reconfigured the module. I've just also changed the rate setting, which is now back up to 5 Hertz as well, because we can move from that 3 Hertz setting that we have to do with the 3-sat system up to 5 Hertz on the 2. We'll do a cold boot and I'll just demonstrate now the difference. You can see the speed difference as it's now scanning the sky and it's beginning to pull the sat data in. Again, this is a complete cold start, so there's no Almanac data there either. So it's just now going to do the search on the sky and then it'll start bringing all of those other sat systems in. Now, when it does this, you can see it does behave a lot faster than you would see on the 3 Hertz option. It's already beginning to bring in the additional satellites on GLONASS. You can see we have 1, 2, 3 with another 2 sitting below already, and it does not take long to start bringing those sats into the mix. If I start looking at the accuracy measurements, it is already dropping down to very good low levels. It's at 0.62 of a meter already, whereas at this point on the 3-sat system, it was sitting at 1 meter and it took a lot longer to get down to lower levels. And to me, in all of my testing, it's just clear that when using it in the 2-sat system, it's able to get all of that acquisition quicker and it's able to quickly get to more accurate data than it can in the 3-sat in itself, simply because of the increased refresh rate. So as you can see, it's a little while later, a few minutes or so, and you can see we've got a lot more sats on board now. We're currently using 14 in total, and as I mentioned, that is less than I saw on Galileo and BeiDou right now, but I haven't been used to seeing that 19 level of satellites that we're finding today. It does just prove the difference you do have on time and date at the same location. At one point in time, there may be loads of sats overhead, and another point in time, it may be much less. And my observations show that when the module is running at a lower rate, that is when you will see problems with lower sat counts, especially, as I've said, with that behavior I've seen where it doesn't always bring those other sats in. It seems to sit there and wait some time, and I do wonder if that's some specific Ublox behavior, or is it related to the signals simply not being strong enough. One last thing I want to address before I'm going to go into a sort of summary and overview of what I think the situation is, and I'll talk about that a bit more in a minute, is regards to the Almanac and Ephemeris data and that SQI Flash thing. As I've said, there's no SQI Flash, and the module is storing the Almanac and Ephemeris data on board its internal memory. If you don't know what Almanac and Ephemeris are, they're basically positioning data info for the module that help it get acquisition quicker, but it isn't a major difference in this day and age. As I've said, the GPS module doesn't have that SQI Flash, so it is storing it on board the memory in the 8030 chip. But I did just want to make it clear that in my tests, whilst it is sort of holding that data for a few hours, after a few hours, that data is lost. It is not permanently storing it. It is simply storing it for a short period of time. And my observations are that overnight, certainly that data is going. I do, though, just want to make it clear that by losing that data is not a reason in itself for users seeing very long acquisition times. In this day and age, the GPS systems are more than capable of getting good lock very quickly, even without Almanac data being stored. If you don't know what Almanac is, think of it as a bit of a map of the sky telling the GPS modules what satellites should roughly be there right now. And the ephemeris data is more accurate, specific positioning and timing data for each individual satellite. This data is downloaded from the satellites themselves. For instance, the Almanac is going to have to be downloaded for each constellation, and that may be having a play into some of the long times that we're seeing, because rather than it having to download 2, it's having to download 3. And I do wonder if that behavior plays into what I've seen with it sometimes hanging before going on to the other sats, and whether it's because there's a delay in downloading the Almanac data. But it isn't something I would expect to cause GPS lock times to go in excess of 5, 6, 7 minutes. It might push it into 1 or 2, but it isn't going to be causing the very long lock issues that people have been seeing. Now, at this point, I could spend another hour walking you through all of the data that I have collected on this module. I have Google Sheet full of all sorts of stuff, including acquisition time tests between the modules in the different modes, testing of high power, balanced power, and the power saving modes, as well as the different rates. However, all of this has given me a feeling, or sort of a direction, that I'm going to share with you now with regards to what I think might be going on. But to be clear, I cannot tell you for sure, because I still need to do a lot more testing. I would love to test an actual Mavic 3 module, hook in a permanent UART, and see not only what DJI's own configuration is, but also monitor it when these issues are happening. I can test the module in the estimated configuration because we know what that should be based on the Ublox specifications, but it would be just good to see what exactly is going on. So it's a few days since I recorded the first bit of all of this, and I've had a bit more time now to digest the info that I've been collecting, as well as some other info from outside sources, and even a bit more from DJI as well. As I've said, this video is not designed to be the be-all or end-all answer, and its primary focus was to talk about the module. And my opinion is that there is no hardware fault with this module at all. That chipset choice is not a problem, as I've already said several times. That information was complete and utter nonsense, and you should not take that as fact, and the fact that they've chosen the automotive chipset has no bearing on the performance of the GPS on the Mavic 3. The reason I wanted to be so clear on that is I have seen how these things can blow up into crazy situations. For instance, I used to actually help run the DJI Facebook groups, and I remember with the launch of the Mavic 2 Pro that there was a user who dropped his aircraft and broke the gimbal. That showed that the gimbal arm was actually glued on, and it very quickly blew up into a massive crap storm of biblical proportions, with people suggesting that there was a design flaw, all of these are bad, and the simple reality was this was one aircraft at fault. I don't think I ever saw more than 2 or 3 of those issues ever posted. So just because there is a lot of noise about something doesn't mean A, everybody is facing the same issue, B, what is being said is correct, and it's going to affect other people as well. We don't know in reality how many users are being affected by the GPS issues on the Mavic 3. The internet tends to blow things up much bigger and louder than they are ordinarily, and whilst there is without question some people who are facing issues, there are many who are not, and just because a number of people are posting similar issues doesn't mean it's exactly the same. People with acquisition times of 1 or 2 minutes may not be having the same issue of people with acquisition times of 5 or 6. Just because there are 3 red cars doesn't mean you should go out and buy a red car, and it really is as simple as don't think everything is necessarily the same cause, because the reality is we don't know, and often issues like this are extremely complex. So as for what do I think is actually going on here, well, my personal opinion based on my own data is that I think it's related to the switch from GLONASS over to BeiDou. Yes, DJI have used a 3-sat system in the past on the Air 2S and Mini 2, but that was using GPS, GLONASS and Galileo. This time on the Mavic 3, they've switched out GLONASS for BeiDou, and I personally think the overall performance differences we're seeing are simply as a result of that changing constellation and the different performance that offers. Yes, with a 3-sat system, they are having to clock the modules slower, but I don't think the slower clocking itself is the cause. But if you add in that slower clocking and the lower satellite level that is often seen on BeiDou, I think that's most likely what is playing into it. Now, that isn't to say some people are not facing some very real issues, but that isn't to say they're the same issues as everyone else. It is interesting that DJI have put out a bit of a statement saying they found the issue and they're going to be releasing a firmware update again, and they are aware that some users in high latitude areas may be facing some issues. This would actually imply again that it is related to the constellation they're choosing, i.e. BeiDou and Galileo, rather than actually a hardware fault with the system. And what it sort of makes me think is that this could be simply as a result of the areas where you're getting very low levels of horizontal angle on the SAT systems, and this is causing the delay in acquisition, and that sort of bears into what I've seen in the data as well, specifically when using BeiDou and Galileo. Because when you look at those systems, they often have much lower SAT counts, and that means you're not going to get the same levels of horizontal accuracy than you will with Galileo in the mix. As a result of that, my feeling is that any fix may simply be the reintroduction of GLONASS on the system for users who are facing issues. It's possible DJI may offer a firmware that gives users the option of both, or some form of algorithm that chooses between the systems. I could very well be wrong on that though, but there is some interesting data online that does suggest that BeiDou specifically isn't the greatest when you do look at it in high latitude areas. There is, though, still the possibility that some people are having out-and-out Ublox problems. I don't think there's an issue with the Ublox firmware, but you don't know. It hasn't been updated in quite some time, and the use case of this specific 3-sat system isn't actually very wide, in the sense of many systems tend to be GPS GLONASS or GPS GLONASS and Galileo. The choice of GPS, BeiDou and Galileo isn't widely used in the world, so we don't have a lot of data to go from. The reality is there is still a lot of hypothesis at this moment in time, and we still don't have the full facts. I am going to continue to dig into this a little slower than I have been, but I'm starting to dig through the DJI firmware, and I'm trying to understand a bit more about what's going on in that aspect. As I've already said, I'd love to get my hands on a Mavic 3 to do some proper testing. Not sure I'm going to be able to make that happen, but if you would like to support us to try and do that, please do, as I've already said, check out my Patreon. There's a link to it in the description. A massive, massive thank you to all of my patrons for supporting the channel so far. I would not be able to do this kind of investigative content without your support. Furthermore, you can also help us on a single basis via the Buy Me a Coffee website as well, if you're interested in doing that. And again, there's a link to that in the description. Finally, if you are new here and you're not a subscriber, please do consider hitting the button and give the video a like. I would love to hear your thoughts on all of this, so please do put it in the comments. I will try and answer any questions you may have as well. Anyway, that's it from me. I'm going to put this one to bed for a little while. Stay safe. I will speak to you guys again soon.